Broadcast is now starting. All attendees are in listen-only mode.
Good morning and afternoon. Welcome to this live webinar session on portable fire extinguishers, understanding fire classification and rating by application. My name is Kristen Motz, and I am part of the marketing team at Johnson Controls. Today's session will be presented by Danielle Felch, Global Product Manager, Portable Fire Extinguishers for Johnson Controls. I'd like to cover a few housekeeping items before I hand over to Danielle. During the session, all attendees will be in listen-only mode. However, we will be more than happy to answer any questions during the presentation. We have a team of panelists in the background that will be able to answer any questions you might have. So please use your question box in the GoToWebinar panel to send us your questions. If time permits, we will answer questions live during the webinar. The session will be recorded. All attendees will receive the presentation slides and recording within a few days of the session. All participants that stay on for the entire 1-hour session will receive a certificate of completion from Johnson Controls. You will also receive a short survey at the end of the webinar to provide feedback. Now, I would like to hand over to Danielle and wish you all a great webinar.
Thank you, Kristen. Hello, everyone. Welcome to today's presentation on portable fire extinguishers. So in this session, we will explore the differences between what is considered a standard product, a high performance, and a clean energy extinguisher. We will discuss what factors to consider when selecting the right product for various applications and how we make informed recommendations to our customers. I'm your presenter, Danielle Felch, and I bring over 10 years of experience in the fire suppression industry. So I started at Johnson Controls as a floor operator. I used to make sub-assemblies for stored pressure product lines. I did that for some time while I was actively pursuing my degree in mechanical engineering. And upon graduation, I did move over to the manufacturing engineering side of the business. I did that for roughly 4 years, and I moved over to R&D, where I was able to understand how our products were made, how we gain the listings, and how we maintain our approvals over time. So today, I'm excited to share my knowledge and expertise with you, guide you through the world of portable fire extinguishers, and together we will explore the features and benefits of standard products, high performance, and clean agents, so you can make better informed decisions and recommendations to our customers based on their specific needs. So a quick disclosure here, this presentation provides an overview of standard products, high performance extinguishers, and clean agent products. For detailed information, the audience should refer to appropriate standards and regulatory documents, and reproduction of this presentation is not permitted in any form. All right, so today our focus will be on 3 important points related to fire safety. First, we're going to explore the components of a fire and gain a better understanding of fire classification. With this knowledge, it's crucial as it helps you determine the appropriate type of fire extinguisher to use for each specific class of fire. Next, we're going to delve into how current fire ratings are obtained and how they impact the fire extinguisher selection process. Fire ratings are determined based on various factors, including effective discharge time, knockdown power, and the type and size of the fire the extinguisher can handle. These ratings play a crucial role in guiding us towards the most suitable extinguisher for the given application. Moving on, we will explore the different types of fire extinguishers available. And by the end of this lecture, you will have a comprehensive understanding of fire components, fire classification, fire ratings, the different types of extinguishers, and taking all of that into consideration, we can make appropriate recommendations based on the specific applications of our customers. Fire safety is a crucial aspect of protecting lives and property, and having the right knowledge and tools is essential. All right, so let's get started with the components of a fire. So this should look very familiar to a lot of people, the fire tetrahedron. So this represents the 4 essential components required for a fire to burn: heat, fuel, oxygen, and a chemical chain reaction. Without any of these components, a fire cannot occur. When it comes to fire suppression, there are different methods to address each component in the tetrahedron. So when we look at cooling, how do you cool a fire? We use agents that absorb heat. Water is the most common cooling agent and can be applied in various forms, such as a solid stream, a spray, a mist, or a foam on water solution. Fuel removal. So removing fuel from a fire can be very challenging and dangerous, but there is exceptions. So shutting off the flow of burning fuel from a pipe or transferring storage tank contents to an isolated empty tank are methods of removing the fuel. So you're interrupting that chemical chain reaction. Oxygen deprivation. Various methods can remove oxygen from a fire. For example, foam creates a blanket that separates fuel from the air. Carbon dioxide gas and inert gases reduce the oxygen levels below what is needed for combustion. There's different types of fire suppression agents work in different types of ways. So dry chemical agents, what these do is they coat the fuel in a thin layer of dust, thus separating it from the oxygen in the air. You're removing that angle of the tetrahedron. Dry powder. So these suppress combustible metals by adhering to the material. So you're excluding the necessary air for combustion. Clean agents. These are stored as a gas or a liquid. They release to a gas to disrupt one of the three elements needed for the fire sustenance. That's heat, oxygen, or a fuel source. Carbon dioxide extinguishers work by displacing or removing the oxygen required for combustion. They also have a cooling effect due to how cold the temperature of the discharged CO2 is. Our liquid agents interrupt the chemical chain reaction and provide a cooling effect to suppress the fire. So understanding all of these fire suppression methods helps us effectively combat fires and maintain safety in case of emergencies. Fire classifications. So fire classifications are a way to categorize the different types of fires based on the materials involved and the potential danger that they pose. So per NFPA 10, there are 5 main classifications of fire. So first we see Class A. These are the most common fires we see in our daily lives. It involves ordinary combustible materials, wood, paper, cloth, plastics. Class B fires. These are fires involving your flammable liquids or gases. This would be gasoline, oil, propane, or even natural gas. Class B fires spread very quickly, and they are a lot more dangerous than Class A. Class B fires are your fires involving your energized electrical equipment, appliances, wiring, electrical panels. It's important to remember for Class C fires, you should never use water as it can conduct electricity back to the user and cause electrocution. Class D fires are fires involving combustible metals, magnesium, titanium, sodium, or potassium. Class D fires are less common, but they require specialized extinguishing agents to suppress them. So by understanding these fire classifications, we can better assess the risks and determine the appropriate method to extinguish or control the fire. So remember, in any fire situation, safety should always be the top priority. So it's crucial to follow established protocols and seek professional help if needed. Different types of fires require specific suppression agents to effectively extinguish them. So there are typical suppression agents for each fire class that was previously mentioned. So the typical agents for Class A's include ABC dry chemical, clean agents, water or foams. Again, the agents work by cooling and smothering the fire to deprive it of oxygen. To suppress Class B fires, the agents include ABC, BC, and purple K dry chemical agents, carbon dioxide, clean agents, or foam. So all of these agents work by smothering the fire and interrupting the chemical chain reaction necessary for combustion. For Class C fires, which involves the energized electrical equipment, the suitable agents would include ABC, BC, purple K dry chemical agents, carbon dioxide, or clean agents. Suppression agents for Class D fires, which is the combustible metals, it's a dry powder that's specifically designed for the type of metal involved. So these agents, again, work by forming a barrier to prevent the metal from reacting with oxygen. The typical suppression agent for Class K fires, which involve cooking oils and fats, is a wet chemical agent. So this agent reacts with the burning oil to form a soapy foam-like layer that cools and suppresses the fire, and it prevents reignition of those greases. NFPA 10 also introduces hazard classification, which is synonymous with what used to be referred to as low, moderate, and high, but the terms now are light, ordinary, and extra. They help us to categorize and define the level of potential danger associated with each of the particular hazards that we just went over. So let's go a little bit further into the light, ordinary, and extra. So to summarize NFPA 10, light hazard occupancies are places with low amounts of flammable materials and low rates of heat release in case of a fire. So these places usually have a normal amount of flammable furniture and less than 1 gallon of flammable liquids in each room or area. So a good real life scenario of a light hazard could be a small office space or a retail store. So in this scenario, the fire hazards present, or the fuels, are paper, cardboards, think of your office furniture, your desks. The potential sources for ignition could be electrical equipment like computers or printers or even lighting fixtures. The occupancy of the space is typically low to moderate and the fire risks are relatively contained. So the light hazard classification is based on the level of fire risk and the expected fire growth in a potential given area. So NFPA 10, again, categorizes fire hazards into light, ordinary, or extra, depending on the fuel load, fire growth potential, and occupancy type. For this light hazard scenario, fire extinguishers with appropriate ratings such as a 2A 10 BC might be suitable. These extinguishers are designed to effectively combat fires involving your Class A, your Class B, and your Class C fires. It is important to note that even in light hazard scenarios, fire safety measures, including proper fire extinguisher placement, regular maintenance, and employee training with a comprehensive fire emergency plan should be implemented to ensure safety of the occupants. Again, light hazard is less than 1 gallon in any room or area. Moving on to ordinary hazard. So ordinary hazard occupancies are places with moderate amounts of flammable materials and moderate rates of heat release in case of a fire. So these places may occasionally have more flammable materials than usual. And the total quantity of flammable liquids typically ranges from 1 to 5 in each room or area. A real-life scenario of an ordinary hazard could be a manufacturing facility or a storage warehouse where the fire risks are greater than what is present in a light hazard environment. So in this scenario, the fire hazards present may include ordinary combustible materials, wood, paper, all up in racking, but it might be in larger quantities or with a higher fire load compared to the light hazard setting. So the occupancy may also involve activities that generate more heat or sparks. Think of welding, grinding, or cutting operations. There might be more flammable liquids or gases stored in or used in this facility. The ordinary hazard classification is based on the level of fire risk and the potential fire growth and how much it can spread. Again, so for an ordinary hazard scenario, fire extinguishers with higher ratings, such as a 4A 20 BC or a 10A 80 BC, may be appropriate for these settings. The extinguishers have a greater capacity and effectiveness in extinguishing the fires that involve the Class A, Class B, and Class C fires. It's crucial to implement additional fire safety measures in ordinary hazard environments, including detection systems, proper storage and handling of flammable materials, and employee training on fire prevention and response. Again, regular inspections and maintenance and testing of fire extinguishers should also be conducted to ensure their readiness in case of a fire emergency. Again, ordinary hazards have 1 to 5 gallons of flammable material in any room or area. So moving on to the extra hazard, these occupancies are places with high amounts of flammable materials and rapidly developing fires with high rates of heat release. So these places are involved in the storage, packaging, handling, or manufacture of flammable materials and have more than 5 gallons of any flammable liquids in each room or area. So a real life scenario of an extra hazard could be an industrial facility or a chemical manufacturing plant, where the fire risks are significantly higher compared to the light and ordinary hazard environments. And also in this scenario, the fire hazards present include highly flammable or combustible materials, such as volatile chemicals, fuels, or gases. And the occupancy may involve processes or operations that generate intense heat, produce large amounts of combustible dust, or involve highly reactive substances. The fire risks in an extra hazard environment are typically more severe and require specialized fire protection measures. So the extra hazard classification is based on the level of fire risk, the potential for rapid fire growth, and the presence of highly hazardous materials. So for an extra hazard scenario, fire extinguishers with specific ratings or specialized extinguishing agents may be required. These extinguishers are designed to combat fires involving highly flammable or reactive substances, combustible dust, or specific hazards unique to that environment. So in addition to appropriately rated fire extinguishers, it is essential to have comprehensive fire protection measures in place, such as automatic fire suppression systems, specialized fire extinguishing agents, designated emergency response teams, and strict safety protocols. Again, regular inspections, maintenance, and testing of fire protection systems and equipment are crucial to ensure that the effectiveness in mitigating the higher fire risks associated with these extra hazard environments. Again, extra hazards have more than 5 gallons of flammable liquids in any room or area. All right, so now we're going to get into understanding fire rating performance. So first, I think we need to understand the difference between an expert firefighter and a novice. So what it really comes down to is their level of knowledge and experience in fire safety and firefighting. An expert firefighter typically possesses extensive training and experience in dealing with various types of fires, fire behavior, and the proper use of firefighting equipment, which includes fire extinguishers. On the other hand, a novice may have limited or basic knowledge of fire safety and firefighting techniques. Most novice users have never touched a fire extinguisher. To obtain a fire class rating, the expert must extinguish a fire that is 2.5 times as much fire as a novice is expected to extinguish. So for example, if an extinguisher denotes that it has a 40B rating on the back of the nameplate, that tells you that for the manufacturer to be able to claim that 40B rating, the expert had to extinguish a 100 square foot pan fire to get that rating. So essentially, the manufacturers are building a safety factor into the rating to ensure that in the event of a fire, someone who has never touched a fire extinguisher has a good chance of putting the fire out. UL conducts performance testing on the fire extinguishers to assess the effectiveness in extinguishing specific fire classes. So this testing evaluates factors such as extinguishing capacity, discharge time, effective range, overall extinguisher performance, and other relevant parameters. The extinguisher is tested using standardized fire scenarios and conditions to determine its performance characteristics. By successfully completing these test processes and meeting the specified requirements, manufacturers can obtain UL approval for a specific fire extinguisher rating. The UL mark on the fire extinguisher indicates that it has been independently tested and certified for its intended use, providing confidence in effectiveness and safety. So fire extinguisher ratings might seem like mysterious codes and numbers on the back of nameplates, but they do serve a very important purpose in indicating the type and size of fire that a particular extinguisher can effectively combat. So all fire extinguishers have ratings stamped on the operating plates. It's usually a combination of numbers and letters. For Class A ratings, to ensure that the extinguisher can put out fires, Class A ratings ensure that the extinguisher can put out fires involving wood cribs, wood panels, and excelsior material. So excelsior material is a softwood packing that comes in box of fragile things that you might order in the mail. That is the fuel that we feed the wood panels with for the fire. Wooden cribs grow in volume for each A that you're going. So for example, a 1A crib is a 20 by 20 by 20 inch cube. And what this is representing when you're doing the UL testing is a deep-seated fire. The wooden panels are different in size based on the A rating as well. So for example, a 2A panel is 10 feet by 10 feet, and you need 26 pounds of Excelsior material to feed that wood panel fire. As soon as a member breaks on that panel, you can start fighting the fire. This is simulating a fire in a wall in a building. So for the A ratings, the number represents the water equivalency. So with each A, it is equivalent to 1¼ gallons of water. So an extinguisher that has a 4A rating, it means that the extinguisher is equivalent to about 5 gallons of water. The B ratings require the extinguisher to repeatedly extinguish flaming liquid fires. So based on the size of the B rating, that determines the square footage in pan fires that you have to extinguish with UL to get those ratings. Class C ratings involve passing specific electrical conductivity measurements. This ensures safety when dealing with electrical fires, that it is not conducted back to the user. B and C ratings indicate the square footage that the extinguisher can handle for the specific fire classes. So for example, if it has an 80B rating, that means that the extinguisher can effectively combat an 80 square foot Class B fire. There are no numerical ratings for D or K fires, as these are designated for specific uses. So understanding these ratings, it is crucial when selecting the appropriate extinguisher for a given situation. So NFPA 10 provides guidelines for building protection and occupancy hazards. Fire extinguishers should be provided based on the fire hazards present or anticipated to be present, whether they are Class A, B, C, D, or K. The numerical ratings help in the selection process by considering factors such as the fire class the extinguisher can handle, the square footage it can combat, and the maximum travel distance for effective use. So by understanding and applying the fire extinguisher ratings, we can make informed decisions in selecting the right equipment for fire protection in various environments. It is important to note that when selecting an extinguisher, you shouldn't solely rely on the rating listed on the nameplate. So for instance, a high flow 10-pound ABC extinguisher may have a lower rating when compared to a standard extinguisher having a 4A 80 BC rating. But when you look at the high flow, it has a 1A 20 BC rating, but it offers increased knockdown power and firefighting capability due to the higher discharge rate. NFPA 10 provides specific guidelines for selecting extinguishers based on the different fire hazards. So for pressurized liquid and gas fires, large capacity dry chemical extinguishers with a discharge rate of 1 pound per second or more and a capacity of 10 pounds or greater should be chosen. Similarly, for three-dimensional fires and obstacle fires, you require a high flow extinguisher. So when customers request a specific rating, such as a 20-pound 80 BC fire extinguisher, it's important to explain to them that there is a direct correlation between the rating and the effective discharge time of the extinguisher according to the UL rating system. So even if an extinguisher is capable of extinguishing a 1,000 square foot pan fire, if it has an effective discharge time of only 8 seconds, the highest rating that it can obtain with UL is only a 20 BC. So that means that customers may need a fire extinguisher that delivers a greater knockdown power rather than solely focusing on the rating. Understanding this concept is crucial when considering standard or high performance extinguisher products. Effective discharge time is a significant factor in determining the rating, and it is important to select extinguishers that provide sufficient knockdown power and fire suppression capabilities for the specific hazards and requirements. By considering these factors beyond just the rating, such as the discharge rate, the effective discharge time, and the specific hazards, you can make informed decisions when selecting the most suitable fire extinguisher for the customer's needs. All right, so standard compliance extinguishers are designed for commercial markets with light to ordinary hazards. These extinguishers come in various options to address different types of fires. So we have stored pressure extinguishers with dry chemical. These are versatile and effective in extinguishing fires caused by common combustible materials such as wood, paper, and cloth. They are suitable for general use in commercial settings. Carbon dioxide extinguishers work by smothering the fire, displacing oxygen, and suppressing the flames. They are well suited for specific applications such as furnished rooms, printing presses and pump rooms, and electrical power panels. It is important to be familiar with the type of hazard being protected by the CO2, as there is a risk of thermal shock after discharge. This makes it less suitable for applications like archive or data centers, where the risk of data loss from thermal shock is significant. Class K or kitchen extinguishers are specialized products designed specifically for commercial kitchens or small kitchen settings or mobile food trucks. They are designed to address the specific hazards associated with cooking oils and grease fires. These extinguishers are essential for ensuring the safety of kitchen environments and preventing the spread of fires caused by cooking activities outside of the hard pipe fire suppression kitchen system. So a reminder, a K-class extinguisher is supplemental to the hard pipe fire suppression system. It is the secondary operation. You must operate the kitchen system first before you use the K-class extinguisher. Water extinguishers are another type of standard extinguisher that has its place in certain settings. So these extinguishers are typically used where oxidizers are present, such as in pool rooms. Depending on their rating, water mist extinguishers can also be used to protect Class C hazards, such as small electrical fires. However, they may not be suitable for use in other types of fires. So it's important to assess the specific hazards present before selecting a water extinguisher. So in summary, standard compliance extinguishers offer suitable options for commercial markets with light to ordinary hazards. From stored pressure extinguishers with dry chemical to carbon dioxide, kitchen extinguishers and water extinguishers, they each serve a specific purpose in addressing different types of fire hazards. So it's essential to understand the specific requirements and hazards of your environment to select the most appropriate extinguisher for effective fire protection. High performance products. So high performance fire extinguishers are considered the first line of defense. It enables individuals threatened by a fire to survive. So think of the places that are very remote. When they call 911 in the event of a fire, it takes them 20, 30 minutes to get on site. So that's why it's essential to have a durable, rugged, and field-proven fire extinguisher that can effectively contain their fires in their incipient stages. In heavy industry, fires are often classified as high risk due to the type, quantity, and condition of the fuel source. The potential consequences can be severe, with significant property damage, personnel injuries, and even fatalities in the worst case scenarios. A high flow extinguisher with a discharge rate of 1 pound per second or higher of dry chemical can significantly enhance firefighting capabilities. This means that you can tackle fires more effectively, especially in scenarios involving three-dimensional Class B fires, gravity-fed fuel, fuel under pressure, obstacles, or fuel in depth. All right, lithium-ion. So I think we need to understand the difference between a lithium-ion battery and a solid lithium battery. It lies in their respective structures and chemical compositions. So a lithium-ion battery is a widely used rechargeable battery. It's in our smartphones, it's in my laptop, in electronic vehicles. It operates using a liquid or gel electrolyte that facilitates the movement of lithium ions between the positive and the negative electrodes during charging and discharging. The positive electrode is typically made up of lithium cobalt oxide or lithium iron phosphate, while the negative electrode is composed of graphite. So it's important to note that there are various products available on the market claiming to protect against lithium-ion battery fire hazards. But many of these products have a Class A or a Class B rating, which typically are used for different types of fires. Lithium-ion battery fires involve a combination of Class A, Class B, Class C, and Class D materials, making it more complex and challenging to handle. Currently, there are no test standards specifically developed to assess firefighting capability of extinguishers for lithium-ion battery fires. And additionally, NFPA 10, which addresses fires in their incipient stages, has not yet adopted guidelines specifically for lithium-ion battery fires. It's important to understand that a lithium-ion battery fire is not simply a small fire that can be easily extinguished. It is a fully engulfed fire that requires specialized attention and expertise. Given the unique nature of lithium-ion battery fires, it is crucial to prioritize safety and follow proper protocols in the event of such incidents. It is advisable to consult with fire safety professionals or authorities to ensure the most appropriate measures are taken to address these fires effectively. Alternatively, a solid lithium battery, also known as a solid-state battery, replace the liquid or gel electrolyte, like in a lithium-ion battery, with a solid-state electrolyte material. This solid electrolyte enables the movement of lithium ions between the electrodes. This solid electrolyte can be made from various materials, such as ceramics or solid polymers. Solid-state batteries have the potential to offer greater energy storage capacity and enhanced stability, reducing the risk of thermal runaway or explosion, like in lithium-ion batteries. Additionally, these batteries may have a longer lifespan and can withstand a wider range of operating temperatures. While there are multiple Class C products available, in this case, Lithium products, to combat those fires, it's important to familiarize yourself with the specific application guidelines provided from the manufacturer. So these products are designed to handle combustible metals, but it's crucial to ensure the proper storage or proper usage and understanding of their limitations. So when we look at lithium-ion battery fires, there aren't solutions available on the market today, because the ones that are available say they have a Class A rating. And what does that tell you? It tells you that that fire extinguisher has successfully put out multiple wood fires with wooden cribs and wooden panels, or they've put out flammable material fires for the Class B rating. So because there hasn't yet been a standard developed to test lithium-ion battery fires, and NFPA 10 has not yet adopted a sixth classification of fire, Class L, there isn't a good option available on the market. The only thing that we can tell people right now to combat this type of fire is to contain it. Clean agent extinguishers. So they play a significant role in fire protection. According to NFPA 10, a clean agent is an electrically non-conducting, volatile, or gaseous fire extinguishing agent that doesn't leave a residue upon evaporation. So the use of halon type fire extinguishers, which is a type of clean agent, should be protected equipment, or where alternative agents could pose.
Danielle, can you hear me? You're
Yeah.
a little choppy right now. You broke up for a second there. You sound fine now.
Okay, I'll start back from the top.
Yeah, from the top, please. Thank you.
All right, sorry about that, everybody. So clean agent extinguishers play a significant role in our industry. According to NFPA 10, a clean agent is defined as an electrically non-conducting, volatile, or gaseous fire extinguishing agent, and it doesn't leave any residue upon evaporation. So the use of halon extinguishers, which is a type of clean agent, should be limited to situations where it is necessary, to effectively extinguish a fire without causing damage to the protected equipment or area, or where alternative agents could pose a hazard to the personnel nearby. So when it comes to evaluating the toxicity of clean agents, both acute and chronic exposures need to be considered. This includes exposures during actual use and accidental discharge. The concentration of the agent can be as significant as its vapor pressure, so acute inhalation hazards must be evaluated. Additionally, exposure to lower agent concentrations over extended periods of time can occur, so subchronic and chronic hazard levels must be determined. The room volume that a clean agent extinguisher can effectively protect during a discharge is listed on the front of every single clean agent and fire extinguisher. It tells you in bold words, in warnings, the amount that it can protect. So depending on the different types of clean agent, the agent that you're using in the extinguisher, they have different room volumes. So for example, a halotron fire extinguisher, a 2.5 pounder, can effectively, they need about almost 400 cubic feet to safely discharge in the event of a fire, if that room is occupied. An extinguisher with FK5112, like in CleanGuard Plus, with 3 pounds of agent, you can effectively protect a room that is only 35 cubic feet. So it's important to understand the type of agent and how toxic it is to understand how big or small the room can be to protect whoever is inside of that in the event of a fire. Additionally, environmental parameters also come into play. So factors such as your atmospheric lifetime, global warming potential, and ozone depletion potential need to be taken into account. So clean agent users must also consider regulatory restrictions on agents. So there are several triggers that indicate the need for clean agent solutions. If there are high value or irreplaceable assets at risk, or if there are concerns about collateral damage or the environment, a clean agent solution is necessary. So these are industries such as data centers, financial institutions, museums, hospitals, art galleries, and clean rooms. They require the use of clean agent extinguishers. So again, why would you consider a clean agent? It's all about business continuity and protection. Clean agents provide effective and efficient fire suppression while minimizing or eliminating cleanup and collateral damage. So they're ideal for safeguarding high value or critical assets. Depending on what type of extinguisher you purchase, for clean agents, our CleanGuard Plus agents have low ozone depletion, low global warming potential, and very low toxicity. So it ensures the protection of both the environment and the personnel when in use. So again, by choosing a clean agent solution, you can prioritize the safety of your assets, the environment, and maintain your business continuity. All right, we're to the wrap up. I love this video. It shows a lot. So it's the same nominal size extinguisher, 3 different types of technologies. So we have a standard stored pressure extinguisher, a standard red line, and a high flow red line. And you can clearly see that the stored pressure, all of these extinguishers are rated for this fire. You can tell that the stored pressure, it doesn't get it out a single time. The standard red line does a really good job getting the fire out multiple times. But that high flow, where you need that additional knockdown power, it is just hammering out that fire. It's honestly taking him longer to light it back up than it is for him to put it out. So fire extinguishers come in different sizes and types and suit various needs. So it's important for fire equipment professionals to assist our customers in determining the appropriate extinguisher for their specific hazard areas. And by doing this, our customers enjoy several benefits. First, they're going to have a customized fire extinguisher that fits their needs and situation perfectly. This ensures that they are well prepared to handle any potential fire incidents and minimize the risk of property damage or loss of life. Additionally, involving customers in the selection process helps them understand the importance of choosing the right fire extinguisher rather than simply complying with regulations. This creates a more consultative relationship between the customer and the fire equipment professional, which adds value to the goods and services provided. So for distributors, prioritizing customer satisfaction and providing proper fire protection solutions leads to better customer relations. This in turn can result in increased sales and service opportunities. With satisfied customers, there's less competition, allowing for better margins and a more professional reputation in the industry. In summary, by working together to determine the appropriate fire extinguisher for each situation, both customers and distributors can benefit greatly. Customers will have a tailored solution to protect their properties and lives, while distributors can enjoy improved relationships, increased sales, and a stronger reputation in the market. All right, we can open it up for questions.
Okay, just as a reminder, everyone, you should be able to type your questions in the question box. And this way we will read them and answer them live. Okay, so we have one question, Danielle. Isn't Class B also for gas fires?
Yes.
Okay.
Yeah, I think I only gave like oil, propane, but yes, it is gasoline, diesel, any flowing liquid fuel is considered Class B.
All right, so please put your questions in the box. All right, here's another question. Would a type K and a type B, oh, it's moving, sorry. Would a type K and a type B be required in a kitchen?
I'm not sure why you would need a Class B extinguisher in a kitchen, because your Class K covers your greases, your animal-based fats, and oils. So like a vegetable oil or a cooking oil, not like petroleum oil.
Okay. What applications would you specify carbon dioxide extinguishers primary?
These are really good for printing presses or pump rooms. So think of specialized equipment with fine motors that in the event of a fire, you don't want the airborne particulates to enter, like from a dry chemical, but using the carbon dioxide, the limitation is that risk of thermal shock. So if you're protecting something like a data server, you could protect it with a CO2, but as soon as you touch something after that discharge, if you're going to touch that server that you just paid all that money to protect with the clean agent, you're going to erase everything on there. So it has its place. It's for equipment that doesn't have to store or have archived information. It is a good place for a CO2 clean agent extinguisher.
Okay. What is an example of a Class A extra hazard?
Class A, paper mill. That's a really good one. They store bales of paper and move them around. And really the source of potential ignition is really just movement. You have to think about all that static electricity from the bales that they're moving around before they make them into actual paper. So that's a really good extra hazard where it's essentially an industrial facility, but most of it's not flammable liquids that they're making. It is paper, which is a Class A combustible.
Okay. Michael and Zach, please feel free to come off of mute and add any additional comments. Next question is, does the Class K cover the vegetable oil storage over 5 gallons?
That's a really good question. Zach, if you could come off mute and maybe help me. So the Class K extinguisher only has a, can you repeat the question for me, Martinique?
Sure. Let me go back to it. Does the Class K cover the vegetable oil storage over 5 gallons?
That'd probably be more of if it's a storage area, because you're probably not going to have 5 gallons of oil, around the cooking equipment.
And I
So that would
believe
probably be more of a ABC or dry chemical application.
I would agree with that because the K-class extinguisher is specifically designed to fight fires in an appliance. So if you're talking about the storage of the grease that goes into the appliance, that will be a different type of fire extinguisher. To Zach's point, an ABC extinguisher would protect that hazard. Meanwhile, in the kitchen, when the oil is in the appliance, that's when you need your hard pipe fire suppression kitchen system and a K-class extinguisher on the side.
Right, Danielle, the K-class is for heated oil in the appliance, like you said.
Yep.
So that
Yes.
oil, separate storage, would be covered separately.
Okay, next question. Are SDS available for review?
Yes, you can go to our Tyco Fire product, sds.com, and you can type in any of the product part numbers or product names, and you can find the SDS information on that website. Also, all of our extinguishers, when you are looking at the nameplate, it tells you the HMIS information, and underneath that, it gives you the link to go to find the SDS information.
Okay, next question. Are high flow stored pressure extinguishers effective on a pressure fire?
Yes, you're going to want to really pay attention to the rate of flow and the nominal size. So there's 10-pound and 20-pound stored pressure options available today. So depending on the size of the fire, you're going to want to pick the agent size appropriately. But yes, it is rated for the pressure fires, and it gives you an accurate rating on what it will be able to protect based on the rating listed on that high flow nameplate.
Okay. Next question. What size extinguishers are required for commercial vehicles? Question.
So by commercial, I'm not sure if you're speaking like large trucks on the highway, or if we're talking about mining equipment. But typically, what's governed by them is not by NFPA, but is by the DOT or MSHA for mines that tell you the minimum fire class rating needed depending on the type of mine. I'm not sure if I answered that correctly, but I don't think I have enough information to.
Andre,
It's too broad.
Andre, if you want to add some additional comments, we can come back to this question.
Okay.
Next question. Have you had or known any of a fire extinguisher to suppress all kinds of fires? A, B, C, D, and K.
No, and I think that's the problem we're facing right now as an industry with these lithium-ion battery fires, because it's a combination of the 5 classes that are defined today, and there is no one fire suppression agent that has been designed to effectively fight all of those in one single fire. The closest we have is an ABC that covers 3 of the 5 classes, but typically it's ABC, BC, D, or K. We do not have any fire suppression in general across the industry that covers all 5 classes today.
Okay. Next question. Do carbon dioxide fire extinguishers perform well outside? For example, outside of a building?
So they do. We have, it depends on the size you're picking and the hazard that you're protecting. Obviously, if you're outside, and you're in, you know, vast space of air, the agent is going to dissipate faster than if you're in an enclosed room. So when you're outside fighting a fire with CO2, you're most likely going to need a 50 or 100-pound wheeled unit to combat those fires. You're going to need more gas to put out that fire that's outside.
Yeah, Danielle, I'd like to add too that the environment, you know, the weather can play, you know, into that as well. If it is a high windy day, it is going to be more difficult to extinguish a fire with a CO2 extinguisher.
Very true.
Okay, great. Next question. What would you suggest for computer rooms, CleanGuard or CO2?
So for computer rooms, again, you are most likely storing or archiving some pertinent, important information. So in situations like that, you are going to want a CleanGuard Plus extinguisher installed in that room for protection.
Okay. How many fire extinguishers are required for a restaurant over 1,000 feet? Which class of fire extinguisher is needed?
So for a restaurant, if you look in NFPA 10, I did have it in one of the slides. I'm not sure if I should go back to it here quickly. But in NFPA 10, they give you a table on the minimum fire class ratings needed to protect the specific hazard and how far you have to travel. So right here, if you look, if you have to travel, you know, 75 feet and it's a light hazard, you just need a 2A extinguisher. So you need to take this into consideration when you're looking at the entire space, how far you need to travel between extinguishers. So that's how you're going to install them. And for a kitchen, it's going to be 2 separate hazards. So you're going to have the area where everybody's dining and eating the food. So that's going to be, you know, a standard ABC extinguisher would fit in that scenario, versus the kitchen side of the restaurant is going to have your appliances and your oil. So that's where you're going to need to install your K-class extinguisher.
Okay. Next question. Safety data sheet available for extinguishers that are not pressure water. I don't know if that makes sense.
I mean, I believe we have SDS sheets for everything, but when you look at the water extinguishers, those are sent empty. So there wouldn't really be an SDS because the SDS is notifying you of the hazard materials contained in something. And because the water extinguisher is shipped empty and filled with water, which is not hazardous, I don't think a SDS is necessary. Zach, I'm not sure if you know if we have an SDS, but I don't think there is for those reasons.
Yeah, that question's a bit odd.
Okay, next question. What are the primary applications where water mist extinguishers are used?
I've actually been seeing them used in a lot of MRI rooms. And they're more prevalent in financial institutions. So those are a couple of applications where I've seen them installed over a clean agent, or where they're typically used. Zach, if you want to add more to that.
I'm trying to find the question right now.
They were asking
There's
for
so many that are popping up.
They were asking for additional application examples where you would use water mist.
We don't have one. But I mean,
Right.
typically in they call out an NFPA 10, where you have the oxidizers. That's going to be really a huge area that could be used in. So we're typically like pool chemicals are stored in a hotel.
Right, like hotels. Yep.
Yeah, that's definitely something that would be great to have that type of product maybe one day.
Okay. Andre followed up with his commercial vehicle question. He was referring to a service technician vehicle, for example, a delivery van.
A delivery van. Okay, so we'll think of it, when we talked about the light, ordinary, or extra hazards, what you're trying to quantify is the amount of flammable material. So in a service van, how big is the van? Is it full of boxes, and does it have, containers of, say, paint or I don't know, lawn material, stuff like that? You're going to want to quantify the fuels present, and then knowing how big or how much there is, you can get a properly rated fire extinguisher. But I would assume, because it's a van, you're not going to need anything more than from a 2A to a 4A extinguisher, or the size. So a 2A 10 BC to a 4A 80 BC, in my mind, would be sufficient to fight that fire.
Okay, so we have 3 minutes left. I'm going to, and you're welcome, Andre. I'm going to ask this last question. And again, just as a reminder, please complete the survey at the end of the session. And also, if you've attended the entire session, you will receive a certificate that will be automatically sent to you after this session, and probably in another couple hours. Again, thank you for all your great questions. And so Danielle, here is the last question. What is the size to be used for aircraft hangars, and the distance to be respected?
So I would have to, there's a lot of things that we need to consider for the aircraft hangar. Again, which classifier you're trying to protect, what is the square footage of the building? Because then on those tables that I just showed previously, it tells you, based on if it's a light, ordinary, or extra hazard, the amount, the minimum fire class rating, and then the minimum or the maximum distance that is allowed to be between those. So based on that, you can tell, okay, if I have a ordinary hazard, I need a minimum of a 2A rating, and I can't travel more than 75 feet from one extinguisher to the next. So that's how you can kind of define how many extinguishers you need to protect an area. But first, you need to define the amount of fuel and the potential for fire growth, and categorize it as light, ordinary, extra. And then you can follow the Class A or Class B hazard guidelines per NFPA 10. And again, those are minimum. Go for it.
I'd like to add something, Danielle, is in an aircraft hangar itself, where airplanes are going to be present, you cannot use an ABC fire extinguisher. It must, for your A-type ratings, you need to use water, and then you need a purple K dry BC dry chemical, because ABC is corrosive to the sheet metal for airplanes. And the FAA, excuse my voice, does not allow any kind of ABC extinguisher near the operation of aircraft.
Those are great points. Thanks for bringing those up, Mike. Okay.
Okay. So thank you again, Danielle, for a great presentation. Lots of positive feedback in the comments. And thank you for joining today's webinar. Have a good rest of your day.
Thank you, everyone.